Look at this. This is a double slit interference patterns. Focus on the central bright fringe. It is so dense, right? And also the central part is very bright. Now look at the single slit diffraction patterns, and you can see that the single slit diffraction pattern and double slit interference patterns are very similar. Now let's collect data. Look very closely how this intensity curve change with position. Okay, a beautiful peak. Beautiful peak. Next, let's record some data. So this is central maxima. This is the first order maxima. So I have symmetrical first order maxima. So there's another first order maxima, the second order maxima, and somehow third order maxima is missing. So which means there is obviously single slit modulation. So from the software, I can measure the distance between two adjacent peaks. So that is 1.990 millimeter, which I can measure very accurately. And also, I can measure the distance from the zero order maxima to the missing peaks, which I can use to calculate wavelength. Next, let's do some quick calculation. So let me show you that for a double slit, there's a distance between two double slits is called letter D, or slit separation. But also there's a W, which means slit width. So the slit separation is 0.25 millimeter and width is 0.08 millimeter. This is directly from the manufacturer. And also the X is the distance between two fringe, which I recorded from the software. So by plugging into the double slit equation, so this is the X, which is 1.99 times 10 to the negative 3 meter, times D, which is slit separation, divided by the distance between the double slit to the screen, which I get roughly 630 nanometer. So this is a double slit equations. Second, let's look at the real graph. So in the real double slit experiments, we can see a clear single slit modulation, which means that there's obviously a very clear and very obvious single slit modulation, which you can simply draw a dash line to represent a single slit modulation. So for a single slit modulation, you can see there's a first order minimum. So this one can be measured directly from the software. So delta X is the distance from the central maxima to the first order minimum. Now I plug in for the single slit formula, which is theta equals lambda over B. So B is the width of the single slit. So lambda should equals theta times B. So theta in this case, well, because this is actually a small angle approximation. So by directly measure delta X divided by D, I can calculate theta in radian. And times, so this one, this is the width of a single slit, which roughly gets 630.2 nanometer, which is match my previous values using the double slit formula.